Okay, 8th graders, this video is going to continue with some support on CR number 32. Let's take a look at number 3. It says, Mr. Thompson is buying 2 types of gift cards to give as prizes to employees at a company meeting. He will buy restaurant gift cards that cost $50 each. All right, so he's going to buy restaurant gift cards and they cost $50 each. He's also going to buy movie theater gift cards and they're going to cost $20 each. All right. He has $450 to spend and he wants to buy a total of 15 gift cards. How many of each type can he buy? I'm going to write a system of equations to solve this. I just think that's the easiest way to go about it. But after the fact, I'll suggest another method that some of you might be more comfortable with. So let's write a couple of let statements. Let's let R equal the number of restaurant gift cards. And then he's also talking about movie gift cards. Yep. Let's let M equal your number of movie gift cards. All right. He's going to buy a total of 15 gift cards. So he's going to take his number of restaurant gift cards, add that to his number of movie gift cards, and he knows he's buying 15. That gives us our first equation for our system. Take your number of restaurant gift cards, add on your number of movie gift cards. That's going to be a total of 15. Now we have to incorporate the value of these gift cards. Well, each restaurant gift card costs $50. So if we took 50 times the number of restaurant gift cards, that gives us how much money we would be spending in restaurant gift cards. And each movie theater gift card costs $20. So if you take 20 times the number of movie gift cards, that will give you the amount of cash you spend on movie gift cards. And if you add together the amount of cash you spend on restaurant gift cards and the amount of money you spend on movie gift cards, that will get you to the total money spent. And he wants to spend $450. Lots of ways to solve this system of equations. I am going to use addition elimination. So I'm just choosing to get my m's to match. I don't have a calculator at home, so to tell you the truth, I'm just trying to see what would be easiest for me. And I think the easiest thing for me would be to multiply the entire first equation by a negative 20 so that we could eliminate the m's. So that's going to be my plan of action. So this would be your system of equations. And now I'm going to multiply the entire first equation by negative 20 so that I can eliminate the m's. So I'm just going to put parentheses around the entire first equation and I'm going to multiply by negative 20. That means I'm going to distribute a negative 20 through my first equation. I'm just going to rewrite down here so I have enough room. So negative 20 times r is negative 20r. Negative 20 times a positive m would be negative 20m equals, and then negative 20 times 15. A negative times a positive is a negative, and 20 times 15 is 300. 2 times 15 is 30, and then I just tack on an extra 0. So I've just rewritten my first equation as an equivalent equation with the negative 20 incorporated. So now I'm going to just copy down my second equation right underneath it. I'm going to use addition elimination. So now I'm going to add on 50r plus 20m equals 450. Okay? Addition elimination. So first I had to get one of my variable parts matching with opposite signs so I could get rid of them. That way I'll only have an equation with r's left and I'll be able to figure out how many restaurant gift cards we buy. Okay, so here I'm going to do addition elimination. Negative 20 plus 50. We have more positives, so our answer is a positive 30r. Negative 20M plus 20M, bye-bye, bye-bye, that zeroes out. That was the whole point. Equals negative 300 plus 450 is a positive 150. Okay, let's hope I'm not making any mistakes because I don't have a calculator, so I'm just quick working this out. So now I'm going to solve for R. If I want to solve for R, this is 30 times R. How do we undo that multiplication? We undo that in multiplication through division. So I'm going to divide the left-hand side by 30, which means I'll divide the right-hand side by 30. 30 divided by 30, fancy form of 1. So I'm left with R equals, here it's just to divide numerator and denominator by this factor of 10, but by zeros, and then 3 goes into 15 5 times. So it looks to me like they bought 5 restaurant gift cards. Now I'm going to take either original equation and figure out how many movie gift cards. I'm going to take this original equation, and it's just going to be the easiest to work with in my mind. If you know R plus M equals 15, and we've just figured out R was 5, that we bought 5 restaurant gift cards, 5 plus M equals 15. You can subtract 5 on each side. So all I'm doing is taking one of my original equations, substituting 5 back in place of the number of restaurant gift cards, and then solving that for M. So then I have M equals 15 minus 5 is 10. Must have bought 10 movie gift cards. All right. Now we can just double check that this makes sense. Well, they bought 15 gift cards total, okay? 5 and 10 is 15. And they spent a total of $450. Each of these 5 gift cards each cost $50. So I'm just going to do a quick check. I'm going to do 50 times 5, 0, 25. So it looks like they spent $250 on restaurant gift cards. Each of these movie gift cards cost 20 bucks. 10 movie gift cards times 20 bucks. 2 zeros, and then 2 times 1 is 2. So it looks like they spent $200 in movie gift cards. Well, let's add the amount they spent on movie gift cards to the amount they spent on restaurant gift cards, and let's hope we get $450. Let's see. 200 plus 250, yay, $450. So it checks out that it's 5 restaurant gift cards, 10 movie gift cards. 5 restaurant gift cards, 10 movie gift cards, that's what it looks like. That's what it looks like to me. Another option, you could have just guessed and checked your way through it. You could have taken 5 plus 10 gets you to 15, and then you could have done 5 times 50 is 250, 10 times 20 is 200, added those together and proved that you got 450. So I'm assuming it's a multiple choice. Your teacher would have allowed guess and check, but it's really designed to be a system of equations, and if it was an extended response question on an exam, you'd have to show all work. All right, let's move on. All right, let's take a look at number 4. Oh my gosh, your teachers are very much into systems of equations lately. Okay, I mean, it makes sense. That's the unit you just finished. It says Guy and Jim work at a furniture store. Guy is paid $185 per week, plus 3% of his total sales in X dollars. Okay, so the total sales is X dollars, and it's represented by this equation. So this is Guy. This is Guy's pay. You take the total amount he sells, multiply that by 3%, 0.03 in decimal form, and then add on his base pay of $185. All right, Jim is paid $275 per week plus 2.5% of his total sales in X dollars, and it can be represented by this. So this is Jim's pay. However much Jim sells for the company, he gets a percentage of that, so 2.5% of what he sells. Changing that to a decimal, it's written like this, and then he adds on his base pay of $275. Determine the value of X in dollars that will make their weekly pay the same. So this is the Guy's weekly pay, this is Jim's weekly pay. So this is Guy's. Guys, weekly pay is Y equals 185 plus 0.03x. And then we have Jim's weekly pay, and his weekly pay is Y equals $275 plus 0.025x. Okay, great. And they want to know for what value x will their weekly pay y be the same. So all we're going to do is solve this system of equations for x. They want their weekly pay to be the same. Do you see how this is equal to y and this is equal to y? That means we can set these two pieces equal to one another. We can say 185 plus 0.03x equals 275 plus 0.025x, okay? We're going to say, when will the weekly pays be the same? Oh, let's see. We got to see what value of x causes the y's to equal each other. So you just set the side of each equation involving the x equal to each other and solve for x. Oh God, I don't have a calculator at home, so I get to do this all by hand. I'm choosing to move all of my constants to the right. You're probably going to hate that because a lot of students like to move their constants to the left for some reason. I'm moving all my constants to the right. Maybe you want to too. All right, so 275 minus 185. First of all, these are gone. Bye-bye. So on this side, I have 0.03x equals 5 minus 5 is 0. Can't take 8 from 7. Make that a 1. Make that a 17. 17 minus 8, I hope, is 9. And then 1 minus 1 is 0. Okay, so that's 90 plus 0.025x. Now I'm going to move all my x's over here to the left. Actually, maybe this is how students do it. You move all your x's to the left. So I'm going to go ahead and move this 0.025 to the left, subtract by 0.025x. Make sure you move the 0.025x. Keep the x with it when you're moving all of it from one side of the equation to the other. Bye-bye. Oh, I get to do this by hand. 0.03 minus, I got to line up my place value, 0.025. So I need to include a 0 here. Oh, can't take 5 from 0. We'll make this 3 a 2. We'll make this one a 10. 10 minus 5 is 5. 2 minus 2 is 0. 0 minus 0 is 0. Keep my decimal point. Okay, great. So this is 0.005x equals 90. To solve for x, we're going to divide both sides by 0.005. The operation in between there was multiplication. We undo multiplication with division. I'm going to divide both sides by 0.005. Oh gosh, super. Again, fancy form of 1, x equals, again, I don't have a calculator at home, so I have to do some long division here. This is ridiculous. 0.005 goes into 90 how many times? Well, I have to move this decimal point over 1, 2, 3 places. So I have to take this and move it over 1, 2, 3 places. Oh God, let me just rewrite this. So I'm really doing 5 into 1, 2, 3, 4. Okay. 9 with 1, 2, 3, 4 zeros. Okay, 5 goes into 9 once. 4, drag down a 0. 5 goes into 48 times. And I could keep doing my long division, but now I just see I have to include 1, 2, 3 additional zeros. Hopefully on your calculator. Again, I'm not using a calculator, so if I've made any mistakes here, oops, you know, you're gonna have to work that out, and shame on you if you're just copying from me. I'm gonna be honest. So I feel like when they each sell $18,000 worth of merchandise for the furniture store, they get the same weekly pay. I don't know what the weekly pay is. All we had to figure out was the X. And I'm going to run out of time on this video, so this is going to be my last piece of this one. Again, hopefully I haven't made a mistake in any of my calculations without a calculator, but the process here is correct. Hopefully $18,000 in merchandise is the correct answer. All right, hopefully that helps. I'll do another video for the next couple of problems.